All right, so here's a review for the quizzes for your test tomorrow. All right, so looking at this graph, it gives you the yearly, average yearly precipitation and yearly temperature for these places on Earth. Which location has the climatic conditions necessary for the greatest amount of chemical weathering? So you're going to look for the most. First off, I'm looking at temperature. And so these temperatures are cold, and these three are warm. I'm going to cross out A and B due to this because when you're having chemical, you want it to be hotter. Another thing, so you're left with C and D because A and B are no good. C and D are both warm, but C is at 100 and D is over 200. More is better. So more warm, more rain. It's giving you D. That's the most chemical weathering you're going to get. Which sediment is most easily picked up and transported by wind? Now, I know this says water on page 6, but it can kind of go along with wind because water, remember, water can pick up these the best. So wind would also be able to pick up the lighter stuff the best. So let's look at where the cobbles is. Cobbles are right here. They're pretty heavy. So I'm going to guess no. Pebbles are the next step down. Sand and then silt. Silt is the smallest, the least amount, diameter, least weight. I would think that it'd be the easiest to pick up, and that's the answer. All right, general probability of flooding decreases, which means flooding goes down when there's an increase in this. So flooding will go down if there's an increase in precipitation. No, it'll actually be the opposite. You'll get more flooding with more water. More flooding or less flooding with more runoff. That means there's more water coming in there. That's a no. How about snowmelt? Snowmelt makes more water, more precipitation. So yeah, that'd be a no. You'd be left with infiltration. That means sucking into the earth or into the ground. All right, looking at this, it again gives you yearly precipitation and yearly temperature. The difference is it tells you the type of weathering that's going on. And it wants to know which type of weathering is most common where it's 5 degrees Celsius. So I'm going to put a line there first. And average yearly precipitation about 45 centimeters. So I'm going to guess it's like roughly right about there. Put a line across. And then here's my bullseye. It's in slight frost action. That's your answer. All right, this one tricked a bunch of you. And so we as humans do cause issues or weathering within the earth. And in this case, you have pollution causing limestone caves to form. Limestone caves form with acidity. And making precipitation more acidic, how do we do that? Well, that's one of the reasons, a big hot topic with global warming. It's the burning of fossil fuels, cars, plants, our carbon emissions. The more of that, the more carbon dioxide causes more carbonic acid, which breaks down limestone. All right, so this is a demonstration using a solid limestone and powdered limestone. So here's the solid, there's the powdered. Why does the powder react faster than the solid? Well, this is back a couple lessons. It doesn't have to do with volume or chemical bonds or lower density. It has to do with surface area. Now, surface area in a nutshell is if I have a big old chunk, is it easier for the water to touch every single bit and piece of a chunk or tiny ground up pieces? So when I'm looking at that chunk, water can only touch the outside. It can't touch anything on the inside. Now, if I was to pulverize that, I could then be able to touch that inside because everything's been broken up, which causes more surface area of that, that amount. So more surface area, the faster it's going to react. All right, looking at this in your reference table, most water vapor enters the atmosphere by process of. Well, remember, we're just going over, this is the water cycle. What did we deal with the water cycle? Did we talk about conduction and convection? Not so much, not this unit at least. Radiation and condensation. So condensation, yes, a little bit. That's to form clouds, but that doesn't get the water vapor into the atmosphere. It's getting it out of the atmosphere. So that's a cross out. Absorption and infiltration. So infiltration, we talked about that. That's where it is going down into the plants, or going down into the soil so that it can go up into the plants. But that's not going into the atmosphere, so that gets crossed out. You're left with evaporation and transpiration. Absolutely. That's water going to vapor into the atmosphere, and trees basically spewing out or breathing out the water from the stems, grass, trees, and stuff like that. So those two together, absolutely. All right, looking at this is granite bedrock with cracks. Water has seeped into those cracks and frozen. There's my huge hint. The arrows represent directions in which the cracks have widened due to weathering. Well, what type of physical weathering is shown by the diagram? It just told you water seeped into the cracks and froze. Enlargement of cracks because water expands when it's freezing. Freezing and froze. Absolutely. It gave you the answer in the question. All right, so we see a sand dune, a coastal sand dune. There's no water around it, so this sand dune was most likely formed by, well, it's not water. It's got to be wind because it's not underwater. This is coastal. It's by the coast. It's a sand dune. And remember, when we're looking at this, we're going to, number one, what's left and right? Well, here's my left, here's my right. And when I'm looking at steep is deeper, is leeward, deep. This is the leeward side. I want the windward side. That's where the wind is blowing from. Windward is the gentle slope. So it's from the right. Okay. Number 10, which activity demonstrates chemical weathering? That means changing from one substance to another. Well, freezing of rocks and cracks, we know that's physical. That's frost action. Abrasion, that word sounds familiar. Listen to this. Abrasion of a stream bed by tumbling rocks. It's not that, but that may come into effect in a little bit. Grinding of talc. Yeah, that's just kind of like abrasion, only you're personally doing it. You're left with dissolving of limestone. Absolutely. That's breaking it down. All right, last but not least, base your answer to the following questions on this. So this block diagram represents a region of Earth's surface and bedrock beneath the region. And what you see, the cross section, is these sediment particles are going down the bedrock in the water, in the stream. And what is the process responsible for producing the rounded shape? Something just told me about rounded shapes, right? Abrasion of stream bed by tumbling rocks. Abrasion causes those smoother particles. They get smaller and smoother. So abrasion. This gave you the answer right before it. All right, let's look at the next question. This is in the Stream and Glacier quiz. Deep parallel grooves and scratches. Striations are found on the surface of some limestone bedrock in New York State. These scratches and grooves suggest the surface was abraded by wind-blown sand. Scraped. Ooh, scratch, scrape. That's your answer. Scraped by continental glacier. When you have grooves and scratches on bedrock, it's by scraping glaciers. Blah, blah, blah. What will the most probable arrangement of rock particles deposited directly by a glacier? Remember, when you're looking at erosion or the movement of rocks and sediments, wind and water have those sorted. You have the horizontal and vertical. So I know A and B are absolutely crossed out. And usually when you have sorted, you have layers. Well, if you're unsorted, literally glaciers they're like, when they melt, they're just like, bleh, and they just drop everything. There's no sorting, there's no layers, it's just bleh. So your answer is going to be D. All right, this last one right here, number 3, not last, but we're looking at this valley. And you notice if you were to draw a line with the valley, it'd be this. What characteristic of this valley supports the inference it's glacial ice? So it's U-shaped. If it was V-shaped, it'd be a river with a V. But this is U-shaped, it's a glacier. All right, looking at this, A to A apostrophe. It's a profile, it's a side view. If I was to cut it in half, I'd see what it looks like on the side. So which cross section would this represent? Well, first thing I got to figure out is where is the erosional side, which is the depositional side. The erosional side is the faster side. It's the side that's going to, it's the widest side. So I know it's going to be over here. Deposition is on this side. That means it builds up on this side, it takes away on that side. So A is out, B is out, C is your answer. All right, let's look at the next one. So the deposition in Dolphin Bay, near location D, is caused mainly by, well, let's look at this. Clear Lake is up higher, and you see erosion. It erodes really, really fast here. Deposits a little here, but then you have a lot of depositing right here, right? It says where it erodes, and you have Clear Lake. So what's going on? Think of it this way. Increased wave action. Yeah, no, that has nothing to do with it. Presence of a meander. Yeah, there's a meander, but that doesn't cause this. Difference in salt content. That has no reason. Decrease in current velocity. See, the velocity will go really, really, really fast. It's still pretty going, and then it hits this, and it's like, whoo, slaps into a brick wall and be, okay, now what? Deposit everything. Answer is D. All right, now we have an oxbow lake right here. How is it most likely formed looking at this? Well, originally it was going like this and like that. What happened? The stream changed its path. Crater flooded? Yeah, no. Collapsed cavern roof? No. Fault block subsided? No. The stream just changed its course. All right, number 7. What is the minimum rate of flow at which a stream of water can maintain transportation of a pebble at 1 centimeter in diameter? So first things first, I'm going to find my 1 centimeter right there. And then I'm going to follow it down to figure out my stream velocity. 50. There's your answer. Straight and short and simple and sweet. All right, 2 streams, A and B, carry the same volume of water, but stream A has a greater velocity. It's going faster. The most likely cause of this would be that stream A has more tributaries. We didn't even talk about them. No, that just means offshoots. Yeah, no, that has nothing to do with it. A wider stream bed, same volume, that's not going to affect velocity, how fast it's going. It flows down a steeper slope. Well, yeah, if A is up like this and B is more like this, A is going to go faster. So C is your answer. I don't know. It did not circle. There it is. All right. So looking at number 9, glacial deposit is identified as. So you're looking at this. What is it? It starts at 220 and it goes all the way up here. It is not a U-shaped valley. It could look like a sand dune, but it's from a glacial deposit. So sand dunes don't come from glacial deposits. An outwash plan, we didn't even talk about it. It is a drumlin, that long, thin hill. All right, number 10. Base your answers on the following questions to the map below, which represents 2 bridges. All we have is this. Don't even need the map for it. After a thunderstorm, the velocity of a river at location C was 100 centimeters per second. What is the largest type of sediment transported by this river at this location? So C is 100 centimeters, so I'm going to make a line at 100 centimeters. I don't even need a map or anything. I just know that it's 100 centimeters per second. What is the largest type? Well, let's go up. It goes over here. I'm left with pebbles. And number 11, state the large depositional feature right here forming by an ocean. You saw this a couple questions ago. This is formation of a delta. All right, so this is all the review for all the quizzes. If you have any questions, please don't hesitate to get a hold of me via email or class tag. Besides that, I hope you guys have a great day.